Hey everyone, welcome back to my channel Security Bit.
Welcome to episode 5.
On my channel Security Bit. Please note that this podcast uses audio which is AI generated, but all the content is vetted by a human, which is me.
Ever wish your AI could just get it? Understand exactly how your specific business works, down to the weird jargon you use or the really unique questions only your customers ask.
Yeah, that's the dream, isn't it? And it's actually becoming more real. That's what we're diving into today. Fine-tuned AI models.
Exactly. So we're going to unpack what they are, why they're becoming so important for getting AI that really feels tailored, and crucially figure out when you actually need to go down that route.
Right. Because the big general AI models, they know a lot, but maybe not the specific things you need them to know deeply. Our mission today is to really get clear on fine-tuned models.
What are they? How does the whole fine-tuning thing work? Is it always necessary?
And can you even find models that are already fine-tuned? We'll also look at a specific scenario, sort of a case study, where fine-tuning really makes all the difference.
Okay, cool. So we're looking at how these pre-trained AIs, the ones that have already learned from tons and tons of information, can be sharpened, specialized for very specific jobs.
It's like, think of a master chef. They have great general purpose knives, right? But then they might sharpen one specific knife to a perfect edge just for, say, filleting fish, that kind of specialization.
Nice analogy. And look, we know this can sound technical, but we promise to keep it clear, jargon light, really focus on what you need to know. So let's start at the beginning. What are fine-tuned models? And what's this fine-tuning process?
Okay, so fundamentally, fine-tuning is about taking an AI model that's already pretty capable, it's been pre-trained, and making it significantly better at a specific task.
Pre-trained, meaning it's already learned a lot.
Exactly. These models are initially trained on absolutely massive data sets. Think websites, books, articles, just vast amounts of text.
Wow, okay.
And from that, they learn the basics of language grammar, context, how words relate. They get this really broad understanding of language and, a lot of general knowledge.
So they have a solid foundation.
A very solid foundation.
Yeah.
Now, fine-tuning takes that foundation and adds another layer of training, but this time using a much smaller, highly specific data set.
Specific to what?
Specific to the task you want the AI to perform better. Maybe it's medical terminology, maybe it's writing code in a certain style, maybe it's understanding your company's product manuals.
Okay.
Yeah.
So you're showing it examples relevant to that job.
Precisely. You're essentially showing it, this is the kind of input you'll get, and this is the kind of output I want. It learns from those specific examples.
And the result is a new model.
Sort of.
Yeah.
It's technically a new version of the model.
Yeah.
Optimized based on the examples you provided. It's not built from scratch. It's refined. Think of it like finishing touches on a painting, making those details really pop.
Got it. So it adapts the existing knowledge.
It adapts and sometimes supplements the pre-trained knowledge. And this is actually part of a broader concept called transfer learning.
Transfer learning.
Yeah, it's the idea of using knowledge gained from one task to help learn another task faster and better. The pre-training gives the AI a head start, so fine-tuning is much, much easier and cheaper than training a whole new model from zero.
That makes sense. You're not reinventing the wheel every time.
Exactly. You leverage that existing intelligence.
So what's happening under the hood during fine-tuning? Is it complex?
Well, the core idea is fairly straightforward. You start with the pre-trained model's internal settings, often called weights. When you feed it your specific data, the model makes predictions.
Based on what it already knows.
Yes. Then it compares its prediction to the correct answer in your data. If it's wrong, it slightly adjusts those internal weights to reduce that error next time.
So it's learning from its mistakes on your specific data.
Precisely. It iteratively refines its weights based on your examples.
Does it risk messing up the general knowledge it learned before?
That's a great question and something you manage carefully. Typically, the learning rate, how much the weights change with each example, is kept quite low during fine-tuning.
Lower than during the initial big training.
Much lower, usually. The goal is to gently nudge the model towards the new specialization without drastically overriding all the valuable general language understanding it already has. It's a refinement, not a total rewrite.
Okay, subtle adjustments. Now, I've also heard instruct tuning. Is that the same as fine-tuning?
Not quite, though they're related. Pre-training builds the base knowledge. Fine-tuning often specializes that knowledge for a task, maybe by showing input-output examples. Instruct tuning is more about teaching the model to follow instructions better in the prompt.
Ah, so it's about understanding commands.
Yeah, making it better at understanding how you want it to respond, the style, the format, adhering to constraints you give it. It's less about teaching new facts and more about making it a better conversational partner or tool based on your prompts.
Got it. Pre-training for broad knowledge, fine-tuning for specific tasks or knowledge, instruct tuning for better instruction following.
You've got it.
Okay, fine-tuning sounds pretty powerful then. Does that mean everyone needs it? Is it always required to get good results?
No, definitely not always required. Often, you can get surprisingly far with just good prompt engineering.
Just by writing better prompts.
Yeah, really thinking about how you ask the question, defining the tone, style, giving clear examples within the prompt itself, mapping out the intent. Sometimes that's enough.
Okay. And what about, wasn't there another technique? RDAY.
Right, retrieval augmented generation.
Right.
RGAE is another powerful alternative or complement. This involves retrieving relevant information from an external source, like your company's latest documents or a specific database, and providing that information to the AI within the prompt as context.
So the AI uses that specific, maybe up-to-date info to answer.
Exactly. It helps keep the information relevant and can be very cost-effective, especially when dealing with rapidly changing data, without needing to constantly retrain the model itself.
So prompt engineering and RGAE are good tools. When do they fall short? When should you really start thinking, okay, I need to fine-tune?
There are some telltale signs. If the base model, even with the good prompts in RGAE, consistently fails on certain edge cases or exceptions specific to your domain.
Like the really tricky stuff it just doesn't get.
Exactly. Or if it struggles to consistently give you the output in the exact format you need, no matter how you phrase the prompt.
Okay, format consistency is a big one.
Another is context window limits. If you find yourself trying to stuff tons and tons of examples into the prompt just to get it to understand, fine-tuning might be more efficient.
Because the knowledge gets baked into the model itself.
Right. And finally, latency.
Mm-hmm.
If the model is taking too long to respond, sometimes a fine-tuned model, because it's more specialized, can actually be faster for that specific task.
Faster responses, better handling of edge cases, consistent formatting. Those sound like solid reasons. What are the overall big wins of fine-tuning?
Well, the biggest is probably scaling and adapting the AI to your very specific needs. You get higher accuracy on those domain-specific tasks.
Fewer mistakes, fewer weird answers.
Definitely. Reducing false positives or irrelevant outputs. It means faster, more precise results overall, saving time and resources. The outcomes just feel more relevant and context-aware.
And you mentioned it's cheaper than training from scratch.
Significantly cheaper and faster, yeah. You're leveraging that massive initial investment made during pre-training. Gives you flexibility. You can connect that general AI power directly to your specific data or business logic.
Any other benefits?
Yeah. Potentially shorter prompts, because the model already knows more about your specific needs, which can also help with latency. You can even teach it new skills, like translating natural language into a very specific query language or code format.
Wow, okay. Skills, not just knowledge.
Right. And if you fine-tune locally, you can maintain better data security. Plus, you can keep updating it continuous learning as your data changes.
Loads of advantages. Are there any downsides or things to watch out for?
Yes, a couple of important caveats. One is cost, ironically. While it can save costs long-term, there are upfront costs for preparing the fine-tuning data, running the training process, and then hosting that custom model. So if cost is your only driver, proceed with caution.
Okay, so weigh the upfront versus long-term costs. Anything else?
The other potential issue is sometimes called robustness shift or catastrophic forgetting, though the latter is less common with careful tuning. If you fine-tune too heavily on a very narrow task,
It might get worse at other things.
potentially, yes. It might become less robust or flexible when faced with tasks slightly outside that narrow fine-tuning domain. It's a trade-off between specialization and generalization.
Makes sense. Focus too much on one thing, you might lose sight of others. Okay, so let's say I've weighed the pros and cons, and fine-tuning looks like the way to go. Are there models out there ready for this, or am I starting from scratch?
Good news there. Many of the big commercial LLMs are designed to be fine-tuned. The providers often give you tools, like APIs, specifically for this.
Oh, that's great. So I don't have to build the whole thing. Any examples?
Sure. Platforms like Azure AI Foundry or the Azure OpenAI service explicitly offer fine-tuning for some of their models.
Like which ones?
On Azure OpenAI, for instance, you can fine-tune models like several versions of GPT 3.5 Turbo, and even some of the newer ones like GPT-4o, GPT 4.1, and their mini versions.
Okay, so the popular models are often tunable. Is it available everywhere?
Good point. Not always. Fine-tuning availability for a specific model might be restricted to certain data center regions. So you definitely need to check regional availability with the provider.
Got it. Check the fine print on regions.
Yeah.
What about models like, say, ChatGPT? Was that fine-tuned?
Yes, very much so. Models like ChatGPT and Google's Sparrow weren't just fine-tuned with data examples. They also used a technique called reinforcement learning from human feedback, or RLHF.
RLHF, what's that?
It's basically getting humans to rate the model's responses, telling it which answers are better or more helpful. That feedback loop helps tune the model to be more conversational and aligned with what humans find useful.
Interesting. So multiple layers of tuning. You mentioned Meta's Llama 2 earlier.
Right? That's another great example.
Yeah.
Meta released Llama 2 not just as a base model, but also pre-fine-tuned variants. One specifically tuned for chatbot interactions and another tuned for code generation.
So sometimes the provider does some of the initial specialization for you.
Exactly. They offer different starting points depending on your general use case.
Okay, this is making a lot more sense. To really nail this down, could we walk through a specific example? Like a situation where fine-tuning is clearly the best approach.
Absolutely. Let's imagine a company. They want to use an AI to let their employees ask questions in plain English, but get answers back as queries in a really specific, maybe even non-standard, internal database language.
Ooh, okay. Translating natural language to a very specific custom query language. That sounds tricky for a general model.
It really can be. They might first try prompt engineering, explaining the query language rules in the prompt. They might even use R to pull in the database schema for context.
Give the model the rule book, basically.
Right. But they might find it still makes mistakes. It might get the syntax wrong for complex queries or edge cases. Maybe it hallucinates table names that don't exist.
Because it hasn't truly learned the nuances of that specific language.
Exactly. It's trying to apply general rules, but this language has its own quirks. So prompt engineering and RAG aren't quite getting them to the accuracy they need.
So what's the fine-tuning solution here?
They'd collect data. Thousands of examples pairing natural language questions with the correctly formatted queries in their special language. Critically, they'd include examples of the queries the model previously got wrong.
Learning from mistakes again.
Definitely. They then take a capable base model, like one of the GPT models we mentioned, and fine-tune it on this specific data set of question-query pairs.
So the model sees loads of examples of when someone asks X, the correct query is Y.
Precisely. It starts to learn the specific patterns, the syntax, the nuances of that query language by example. It's like showing, not just telling.
And after fine-tuning?
After fine-tuning, they'd likely still use good prompt engineering, maybe even RA for dynamic context, but with the fine-tuned model. The combination brings the accuracy way up, making the system reliable enough for real-world use.
So it's not always either. You might combine fine-tuning with other techniques.
Often the best approach, yes. The fine-tuning gives the model the core understanding of the specialized task, and prompting helps guide it in specific instances.
That's a fantastic example. It really shows how fine-tuning tackles those specific, high-value problems where general models might stumble. Any other quick examples of where it shines?
Oh, loads. Think about improving how a model handles specific data you retrieve via RAG, or steering it to always use a very specific brand tone or writing style.
Like making it sound like your company consistently.
Exactly. Or improving accuracy when looking up very niche information, adapting to industry jargon, healthcare, finance, legal fields, handling unique customer service scenarios, personalizing recommendations, even generating code in a very specific framework or style.
Basically, anywhere you need deep, reliable specialization.
That's the key. It bridges the gap between general AI intelligence and your specific unique needs.
This has been super helpful. So wrapping up, the main takeaway is that fine-tuning isn't just a minor tweak. It's a powerful technique to make AI models significantly more accurate and useful for particular jobs.
Absolutely. It's not always the first tool you reach for prompt engineering and RAG are vital, but when you need that deep domain expertise or specific behavior baked into the model, fine-tuning offers huge advantages.
So for everyone listening, the question becomes, Where are the general AI solutions maybe falling a bit short for you? Could that challenge be met by the focused power of a fine-tuned model?
And that leads to maybe a final thought for you to consider. Now that you know you can tailor AI this precisely, what unique problems in your field suddenly seem solvable? What new possibilities could this unlock?
A great question to ponder. Definitely explore the resources out there if this sparks some ideas. Thanks so much for breaking this all down.